Oh no, I messed up. There we go. There we go. How's it going, everybody? Yeah. I see we've got 7 people here. What a rip-roaring, amazing start it's going. I mean, that's partly my fault for not giving you advance warning. But those of you that are here, yeah, if you like that intro, that's my year 10s. I think it was Bruno that made it. But yeah. Yeah. So if those of you that are here, I am kind of making an assumption that you have done my previous task that I set, which was to create your notes on Google Classroom, the document for your notes, and you should have those notes open so that you can start filling them up with useful stuff about binary representation. Now, I'm going to take things fairly slow. We're going to have a fairly easy ride into here. Now, obviously, I am not expecting to get everyone in here that is going to be carrying on with computer science in September, which means that inevitably when we go back we are going to have to recap this stuff, but you guys are going to get a head start. It's not so much a pirate hat, it's more, I got this from Boston, Massachusetts. It's a rebel hat for like what Paul Revere wore, when he chucked the tea into the river, if you know anything about American history. But yeah, I've got a new microphone, so I don't have to wear the headset anymore. So you guys that are tuning in now are going to have a bit of a head start compared to your compatriots when we go back, which means that I can then set you some additional challenges when we do go back, and you'll get even better, and then you will all get incredible jobs working for Google and stealing people's data or something. I don't know where I was going with that, but anyway, hopefully I've waffled on enough to give you enough time to get your notes open, or at the very least find a piece of paper and a pen to write with. Yeah. So yeah, nobody expects the Spanish Inquisition, which I assume is what it is based on that very tiny picture I can see there. So how about we make a start? Over the course of the next few lessons, we're going to have a look at data representation and why binary is important and how information is stored in binary. So I don't know how far we'll get. I do have a worksheet which I'm going to put up on the Google Classroom for you to work through. Now, in an ordinary situation, what I would do is give you a little bit of instruction, then say, now go and work on the worksheet, then give you a bit more instruction, then say, go work on the worksheet. But because of the way things are at the moment, what I'm going to do is basically walk you through all the steps for everything and then say, my work is done, now go to the worksheet. Does that sound cool? I'm guessing the no answers mean yes, it's cool. Wicked. Out of interest, does anyone know who this is lurking behind the words binary in my presentation here? Anyone know who that is? I'm not expecting you to know. It's just you get bonus points if you do know. Feel free to shout it in the comments if you know. It's not God. Not quite. Anyway, here's a hilarious joke which you might have heard before. There are 10 types of people in the world, those who understand binary and those who don't. I mean, it's not a particularly good joke, but it does rely on you understanding binary even to get it, so that you can say, well, I get it, but it's not funny. You know, there is a better joke that I came up with, which is there are 101 types of people in the world, those who understand even bit parity checking and those that don't. Again, if you do A level, you'll get that. It's hilarious. Anyway, so some of you might be sat in there thinking, well, that doesn't make any sense. If there's 10 types of people in the world, why do we only have these two here? By the end of this lesson, you'll be able to explain that joke. Okay, so if you're already lost, don't worry about it. By the end of the lesson, you'll be able to look back on this joke and say, aha, that's hilarious, right? Look at this ancient meme. How old is that? But there it is. It's in there. Okay, so the purpose of this lesson, by the end of it all, you should be able to A, explain the difference between binary and denary. You've probably heard the word binary before. Not sure if you've heard the word denary before, but I'm guessing you've probably heard the word decimal before. Okay, so we will we'll look at the difference between those two. You'll be able to explain why binary is so important in computing. Binary underpins everything we do with computers, so you'll be able to explain that, hopefully. And the real focus of the lesson is being able to convert binary numbers into denary. So denary is the numbers that you know and love. You know, the numbers from 1 to 10 and all of the combinations that you can make from those. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, so on and so forth. Every number that you have used in your life up to this point is probably denary, right? Binary is different. It uses just ones and zeros. So we'll have a look at how we go from ones and zeros and nothing but ones and zeros to numbers that are easier for us as human beings to understand. So, what is binary? And by the way, don't wait for me to say to you, oh, write this down, okay? Any of this information, obviously, I'm not just saying it because I like the sound of my own voice. I'm saying it, although my voice, through this new microphone, my voice does sound pretty awesome, right? I'm saying it because this is all information that you need to know, right? So anytime you see this stuff on my screen or any words that are coming out of my mouth that make sense and are related to computer science, it's worth writing that stuff down. Now, you don't have to write it down exactly as I've written it on here. Write it down in language that you can understand. Because remember, you are eventually going to go back to your notes in order to revise for tests and things. Okay, so if this all makes sense to you, you should write it down. If it doesn't make sense to you, you need to ask me and say, what does that actually mean, so that I can explain it to you, and then you'll be able to write it down in terms that you understand, right? But don't wait for me to say, write this down, okay? If you see it, get writing, basically. So binary is a way of expressing number values. Just like your 1 to 10, it can express any quantity of number values, but instead of using 10 different digits from 0 to 9, it uses 2 different digits, 0 and 1. In fact, the word bi means 2. Okay, you've got a bidirectional means 2 directions, right? A bicycle, it's 2 wheels, right? Bicycle, yeah? So the word bi means 2. Den is short for, I think, yeah, I want to say it's Latin, which is 10. So yeah, unicycle. How many wheels has a unicycle got? What's uni? Here we go. We're getting a Greek language lesson here. Is it Greek? No, it's not. It is Latin. It is Latin, because in Greek it would be mono. Yeah, 1. Uni is 1. So I guess it's theoretically possible to have a unary counting system which only uses a single digit, although I'm not entirely sure how far you'd get with that. But there's also things like trinary, quaternary as well. So these are all different number systems. The only 2 that you need to know about are binary and denary, right? It's important, and this is super important, so it's well worth you writing down. It's the only language a computer understands, right? All of you guys that have been learning Python through my videos and typing out those programs, you might think, oh, I'm writing Python because the computer understands Python. No, it doesn't. when you run your Python program, what actually happens is the code that you type gets converted into binary code, which your computer then understands, right? The computer only understands binary. There is a reason for that, which we'll get into when we have a look at systems architecture. But just to give you a quick heads up on why that is. Inside your CPU, there are billions of these tiny little switches called transistors. Yeah, and they can either be on or they can be off, right? And if something is on, that equates to a 1. If it's off, that equates to a 0. Okay. If it's converted to binary, does that make an interpreter into a JIT compiler? And it depends on the implementation. So for those of you that are unaware, JIT stands for just in time. I believe Python does do some JIT compilation. Don't quote me on that though. But in interpreting and just in time compilation they might appear similar, but they are slightly different. Now, you'll be pleased to know you don't need to know the difference between them. Okay? What would happen if you just typed in binary? Well, funny you should say that, because only today in my A-level class, I was teaching students how to program using binary and nothing but binary. The short story is there is a programming language called assembly language, where each individual command in assembly language corresponds to a single command in binary that the computer understands. And when you convert it, what the system does, it just literally takes the word that you've written, looks it up in a table and says, okay, cool, that's this value in binary. So in theory, you can program directly in binary, but you won't be able to do that like through PyCharm or something like that. Okay, so key points. Binary, it's just a way of counting, okay, but it only uses 2 digits, 0 and 1. It's the only language a computer understands because we all know that language. So I'll get onto that. Sorry, I'm looking at the chat. I should be ignoring the chat for now. It's the only language a computer understands because the CPU is filled with these tiny little switches. There are billions and billions of these tiny little switches, which are arranged in specific ways to do funky things. And binary basically looks like this. This is just a random bunch of ones and zeros that are typed. It doesn't actually mean anything. So 10 1110 10 10 10 1100 1100 11001000. By the end of this lesson, in theory, you should be able to convert that number into a Denary value. That's going to be a massive number. There'll be house points in it for anyone that manages to convert that number. All right. I don't know what it is. I just randomly mashed the ones and zeros in there. Okay. Before I move on, are we all clear on what binary is? There's hopefully no one's got any sort of doubts about this stuff right now. You might have further questions, but the stuff that I've explained, does that make sense? Okay. Yeah, so you probably would have covered some of this stuff in year 7 or 8, but we'll be looking at it in more detail. Okay, cool. So let's move on. This is kind of what it actually looks like to a computer, right? I robbed this picture off the internet. I didn't make it. But just to give you an idea of what's actually going on inside your computer, all of those switches, they're either on or they're off. Yeah. Okie dokie. 1 second. Boom. Done. So the switches are either on or they're off. There's voltage coming through them, but the real world is a messy, messy place. Yeah. And we get these sort of like little wibbles. And so the actual signal that goes through your computer is never sort of like straight ones and straight zeros, but it's up. If it's up beyond a certain amount, it will be registered as a 1, and if it's down below a certain amount, it'll be registered as 0. I mean, technically that's not true either, because it's all about when it crosses the line on the rising. So you see here this arrow where it says, oh, it's going up, that's going to be a 1. It's going up again, that's going to be a 1. It's not going up here, so that's a 0. Okay, and it is going up here, so that's a 1, right? Anytime it's going upwards on one of these lines, it's going to be a 1. You don't need to know that. I just thought it was kind of interesting. I just thought that was kind of interesting there. Okay, so one thing that you will need to be doing throughout the course of the course. You're going to be learning a hell of a lot of new words which have very specific meanings in computer science, and you need to be keeping track of what those words mean, right? So what I recommend is that you add a section to your notes. Some people put it at the end of your notes, some people put it at the start. It doesn't matter, as long as you've got a section dedicated to this stuff. Does anyone know what the word glossary means? Or does someone want to look up the word glossary and paste the result in the chat there? No one knows. It's all right to not know. I mean, it's probably not a word that you've encountered much. The back of the book with all the meanings of the words. Yeah, that's generally a good way of saying it. It's kind of like a dictionary, but it's sort of a bunch of words that are relevant to the thing that you're learning about and the meanings of those words. Okay, I searched it on Google. The word doesn't exist. I'm going to put this to the test now. Okay, so let's go glossary. It certainly does exist here. A glossary, also known as a vocabulary or clavis, is an alphabetical list of terms in a particular domain of knowledge with the definitions for those terms. So basically it's a dictionary about the specific stuff related to the topic, if that makes sense. Okay? So in this instance, our glossary, it's all of the terms related to computer science. Okay? Don't wait for me to tell you what words to put in your glossary. If it's a new word and it's a computer sciencey word and you need to know what that word means, add it to your glossary. Okay, so here's your first 3 words to go in your glossary. A bit is a single digit in a binary number. Okay, you will get asked questions like this on the exam, and you've got to make sure you're clear, right? You have to make sure that it's a digit in a binary number, and you have to make sure it's a single digit, okay? Those digits can be one of 2 values. If I say, here's a bit, what could it be? What are the 2 possible values that my bit could be? Yeah, 1 or 0. Okay, so a bit is a single 1 or a single 0. That's it. If you've got 8 bits joined together, they make a byte. You might have heard the term megabyte or gigabyte or terabyte or even petabyte. Okay, these are all made up of bits. Does anyone know how many bytes there are in a kilobyte, out of interest? I mean, does anyone know how many grams there are in a kilogram or meters in a kilometer? Yes. It's not 10,000. It's Will is correct with his answer of 1,000. There's 1,000 bytes in a kilobyte. So kilo means 1,000. Mega, how many bytes are there in a megabyte? Does anyone know? Or how many kilobytes are there in a megabyte? Not 100. Right, okay. So, you guys, I think you guys might need a primer on this, but don't worry, I'll knock something together. So, for reference, 1 byte is a byte. 1,000 bytes is a kilobyte. 1,000 kilobytes is a megabyte. Therefore, 1,000,000 bytes is a megabyte, right? 1,000 megabytes is a gigabyte. 1,000 gigabytes is a terabyte. 1,000 terabytes is a petabyte, and so on and so forth. Okay? You kind of do need to know those different things, but we'll have a lesson where we go over that. Okay? The example that I've put down here, we've got an 8-bit binary number. So there's 8 bits in there. That is a byte. Okay? Now, if you've only got 4 bytes, that's called a nibble. You can spell it either way. Sometimes it's spelt with a Y, sometimes it's spelt with an I. This is an example of computer scientists thinking that they're hilarious. So, you know, bit is 1 digit, a nibble is 4 digits, and a byte is 8 digits. Does that make sense to everyone, yeah? Cool. Right. Yar. Maybe I should do the whole stream speaking like a pirate. Although it's not a pirate hat, I should point out, right? So moving on to the next slide here. It's all well and good me saying to you, oh, binary is just made up of numbers. It's all ones and zeros, right? But what does that actually mean? Okay, now in order to understand what the binary digits mean, I need you to sort of go back to primary school and think about how just normal Denary numbers are made up. Okay, so remember Denary, that's your normal numbers which you are used to using. Okay, I don't know, you might want to add that word to your glossary if you're not sure. Okay, but you already know these numbers. 12, 375, 65,536, right? Let's have a look at how they are made up. And this is not me trying to insult your intelligence. I know you already know this. There is a reason for me going through this, okay? So they are made, you have these columns, right? You have hundreds, tens, and units. This should all make sense to you, yeah? If I had another column to the left here, what would be in that column? If I've got units, I've got tens, I've got hundreds, what would the next column along be? Yeah, thousands. And then the next one. What would the next one be after that? Not millions. We're not going up to millions yet. We've got thousands, and then tens of thousands. That's right. And then hundreds of thousands, yes, and then millions, and so on and so forth. We multiply by 10 each time. Units, that's like a 1. Multiply that by 10 and you get 10. 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000. 10,000 times 10 is 100,000. 100,000 times 10 is 1,000,000, and so on and so forth. That makes sense to you, right? That makes sense. Tell me that makes sense, please. Otherwise, your maths teachers throughout the years have failed you all. Yes, good. It makes sense. Now, hopefully, you're also familiar with this terminology here, right? If I say 10 raised to the power of 2, that's like saying 10 times 10, right? That's 10 squared. If I say 10 raised to the power of 1, well, that's 10 times itself. Well, it's not even 10 times itself. It's just 10 times 1. It's 110 on its own, not multiplied by anything, which is 10. 10 raised to the power of 0 10 raised to the power of 0 is always 1. Anything raised to the power of 0 is always 1, right? And so we can write, instead of writing hundreds, tens, and units, we can write it in this way. Yeah, we can have 10 squared, 10 to the power of 1, 10 to the power of 0. If we were going further on here, we'd have 10 to the power of 3, or 10 cubed. We've had 10 to the power of 4, 10 to the power of 5, and so on and so forth, right? Does that all make sense, what I've just said? I'm taking my time with this bit so that the next bit where we look at binary will make the same amount of sense. Are we all good, yeah? Yar. Good. Excellent. And so, just before I move on, we write the number underneath these, the place values at the top, these magic numbers. Okay? 375, and this is going to sound totally obvious, but I'm doing this on purpose, right? 375 is made up of 3 times 100 plus 7 times 10 plus 5 times 1, right? There's 3 hundreds in there, there's 7 tens in there, and there's 5 ones in there. That makes sense to everyone, right? I know, mind blown, yeah? But there is a reason for me going through this like, you know, meticulously. It's because obviously on the next slide, I'm going to show you how it works in binary, and hopefully that will make you understand exactly what's going on, and in theory be able to use this information for any kind of numbering system. Okay, so let's have a look at binary, right? With Denary we had powers of 10, right? With binary we have powers of 2. And my presentation is so damn good that the word structures is covered up there. Okay, but I've tried to illustrate this using the same table, right? I've written an example number down here. So Denary uses powers of 10. 1, 10, 100, 1,000. Every time you add a new one onto this side, you multiply by 10, right? Binary is exactly the same, but instead of 10, it uses 2. We say that the number base is 2. Binary is a base 2 numbering system. Denary is a base 10 numbering system. Okay, so Denary, you multiply by 10 each time you go up and add a column. Binary, you multiply by 2 each time you go up. Okay, so we start off with 1. Always start with 1 here. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. What would the next number along here be? In fact, what would the next 4 numbers along there be? The next 4 numbers along, we've got 1, 2, 4, 8. What's next? 16, 32, 64, 128. Yes, can we keep it going? What would the next 4 numbers be? In fact, feel free to just keep it going. Just type those numbers as they pop into your head. One, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192, 16384, 32,768, 65,536, right? We could keep on going all night, yeah? One day you guys will be able to rattle off those numbers. Ultimately, it doesn't matter. You will be dealing with bytes at GCSE level. Okay, maybe in some of my questions we'll go a bit beyond bytes, but as long as you know that it's doubling each time, you know, everything's great. Okay, so if you can't remember what those numbers are, or start from the right hand side. write a 1, and then keep on doubling it. Yeah? And so, in my mind, working out what a binary number is, in many ways, is easier than working out what a denary number is. Because look at these numbers under here, right? We only ever have ones and zeros. What this number is telling us is there is 1 8, there are no 4s, there is 1 2, and there is 1 1. Okay? So if we just look at the columns that have a 1 at the bottom and add up the magic numbers, we can find out what that number is. Yeah? We've got 8. We don't add that. 8 plus 2 plus 1 is 11. Okay? Now, just before we get onto that in a little bit more detail, I'm going to do a bit of counting. Okay? You guys all know how to count to 20, right? I'm not going to wait for your response here. I'm just going to start counting. However, we'd have to start at 0. I don't know why one of my zeros is bigger than the other, but in computer science, and this is worth making note of, you always start counting at 0. Do not start at 1. We start at 0. Okay, so if we're counting to 20, and we're just doing this with our normal denary numbers, yeah, we count. We go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And I've paused it here because something interesting happens, right? We've now run out of digits, yeah? We can't, there is no digit after 9. So what happens is we increase the next digit along by 1 and we reset this one to 0. It's kind of like the value is spilling over because the next value would be 10, right? And that's the value that's at the top of the column here. We can't put 10 in a single column, so we spill it over here. And this resets to 0. And every single time, it's like a clock, right? The numbers go up to a certain amount and then they reset. And as soon as they reset, the next number counts up by 1, right? So we then trip over to 10, which is in effect 1 0, 11, 1 1, 12, 1 2, and so on. 13, 14, 15, 16, 17, 18, 19, and then the same thing happens again. Okay, we can't add anything on here, and so we reset that to 0. It will spill over into this column, and it will increase this number by 1 up to 20, right? 20. Does that process make sense? I mean, I bet you've never really thought that hard about counting before, right? But the way that I've explained it, does it make sense what's actually happening there? Rather than you just thinking, oh, after 19 comes 20, right? I want you to start thinking, after 19, we have to increase the tens column by 1 and reset that 9, and that's how we get 20, right? Counting with Captain Smith. Yeah, maybe I'll start another YouTube channel where we do this stuff. But is that all good? Is that all good? Because I want to move on. I want to move on to the next bit where we do it in binary, and then I'm going to set you off on some tasks. Okay, make sense? Just a quick yay or nay. Yep, all good. Cool. Okay, I'm assuming Will speaks for everyone. So let's just do it in binary. Now, ordinarily, if we were all together in a class, I'd stop each time and I'd ask you guys, hey, what's next, right? But I'm just sort of gonna go through it slowly, and I want you to sort of like follow along with me and give yourself a pat on the back if you get it right. Okay, so counting in binary is absolutely no different, right? We're starting out 0 0 0 0. Everything's 0. Yeah, there's nothing of anything. We add 1 and we get 0 0 0 1, right? Which is 1. So far so good, right? Now, if we add another 1, if we were using Denary, we'd get 2. But because 1 is the maximum value we can have in any one of these columns, we're at the same point here as we would be if we were counting in Denary and had got to 9. Okay? And so, when we add 1, what happens is we spill over. we have to increase the next column by 1 and then reset this to 0. Therefore, 2 in binary is 1, 0. Okay? At this point, the light bulb in your head should be clicking, and you'll be thinking, oh, I get that joke now, right? So we're at 2, 0, 0, 1, 0. If I add another 1, I can do that, no problem. We've got 0, 0 plus 1 is 1. So we end up with 0, 0, 1, 1. And that is 3 in binary. However, something weird happens next. Well, it's not that weird when you think about it, right? We add 1 here. We can't go any higher than 1. So that has to reset, and the 1 spills over into this column. So now we're trying to add 1 to 1 again. We can't do that. So we have to reset this to 0, and the 1 spills over into this column, right? And so, if anyone can tell me what the next number in the sequence is going to be before I click the next button, I will give you a thumbs up. Okay? I'm about to click next. What is the next number? If I add 1 to 0, 0, 1, 1, what am I going to get? It's not a bunch of Space Invaders. It is not 1, 0, 1. You've got to be careful here, because we reset this value to 0 before that spills over. And then we reset that value to 0, and then it spills over. And so we get 1, 0, 0. Okay? And then adding again, 1, 0, 1. And then we can't add again, so that gets reset to 0. We spill over here. We get 1, 1, 0, 1, 1, 1. Okay, same deal again. Reset that to 0, spill over. Reset that to 0, spill over. Reset that to 0, spill over. Change that to 1, and we end up with 1, 0, 0, 0. Is this making sense to everyone, right? What I recommend you do, if it's not making sense, what I recommend you do is take some time going over this part of the video again, or maybe writing it down on paper, right? So we've got, I don't know if we're going to, well, let's keep on counting. 1, 0, 0, 1. We should now have 1, 0, 1, 0, 1, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, and then 1, 1, 1, 1. Okay? Oh, I get it now. Excellent. Just a random potato. I'm glad you get it now. Cool. Right. So, with that understanding, let's have a look at something a little bit more challenging, and then I'm going to say to you, hey, the work's up on Google Classroom, have a crack at the worksheet, all right? So, here we have a, what's it called? I've got 8 bits here. What's the name of that? If I've got 8 bits. Eight bits is a byte. Excellent. Cool. Right, so this is the process that you go through, right? I'm going to share up this presentation onto the Google Classroom, so as well as having the video, you'll be able to go through the presentation as well. This is how you convert from binary to denary, right? We're going to convert this number, 1011 0101. Okay? First of all, you draw out this grid, right? Just like if you were in primary school doing some addition, you'd draw out the hundreds, tens, and units columns, and you'd write your numbers underneath. We're doing the same thing here, right? You can either remember that you start from 128 and then halve it each time, or what I normally do is start from 1 and keep on doubling. 1, 2, 4, 8, 16, 32, 64, 128, okay? Once you've got all of those columns in there, you then plug in your binary values underneath. So we had 1, 0, 1, 1, 0, 1, 0, 1. So we feed that into the bottom here. 1, 0, 1, 1, 0, 1, 0, 1. Okay? Next, all we have to do is go through, and anytime there is a 1, we just have to write down the magic number at the top. Okay? So going through here, we can see there's 1 there. So we write down 128. 0 there, so we're going to skip that. We write down, there's a 1 there, so we're going to write down 32. There's a 1 there, so we're going to write down 16. There's a 0 there, so we're going to skip that one. There's a 1 there, so we're going to write down 4. There's a 0 there, so we're going to skip it. There's a 1 there, so we're going to write down 1. So we end up at the end of it with these numbers written down: 128, 32, 16, 4, 1. Okay? And then all you have to do to work out what the number is in Denary is add those numbers together. Right? That's literally all there is to it. You write down the magic numbers for any column where there's a 1 at the bottom, and then you add them up, and that's your total. Okay, does that make sense to everyone? How to convert from binary to Denary? Yeah. So is there something to do with the zeros? No, the zeros just say there isn't, this value doesn't exist in my number. Okay? In the same way that if you had the number 1000, right? That means there's 1000, there's no hundreds, there's no tens, there's no units. Yeah, it's the same. You just skip them. It means that you don't need to add this value on to make up the number. Okay? So that's all you need to do. Now then, going back to that original joke, that original terrible joke that I put at the very start. Another ancient meme here for you. I'm the meme archaeologist. There's 10 types of people in the world: those who understand binary and those who don't. If instead of treating that as 10, you treat it as the binary number 10, yeah? Do we get the joke now? Or, I mean, even if you don't find it funny, do you understand the joke now? Understood. Yep, big brain stuff here. Okay, so just to let you know what I've done. Is that actually assigning? There, boom, it's done. Right, okay, so I have added something to the Google Classroom. If I just show you what it looks like. Just pull it up on here. Presentation. And we'll switch to... Boom. Okay, so kind of looks like this. Let's actually get it so you can properly see that stuff. Boom, there we go. So there's a number of different sections to this worksheet. The first section is just converting nibbles, and I have put the table in there with the magic numbers at the top. Section B is converting bytes. And again, I've done that for you. Section C is converting a variety of different numbers. You'll have to construct your own tables, and be careful, because there are some numbers in here which have more than 8 bits in. So you'll have to think carefully about what the extra values are there. Now, just to let you know, the way that I do my worksheets, I don't expect everyone to just start at the beginning and try and answer absolutely everything, right? If you think that section A is too easy for you, skip it. Start on section B, right? If you would rather sort of test the waters with section A, practice that until you get to the point where you think, oh yeah, I think I've got this, and then you can move on, right? If you feel confident enough to just skip straight down to section C, by all means do that, right? The idea is that you choose the sort of level of difficulty that you want to engage with, and obviously I want you to try and push yourself as best you can there. So let's just get rid of that. That's pretty much it. Okay, so that work is now on the Google Classroom. Have a crack at that. Don't spend absolutely ages on it, but just have a go at that and see how you get on. And if anyone has any questions, then give me a shout either on the Google Classroom or on your Discord or wherever. And that's that. Just before I sign off, though, has anyone got any specific questions or bits that they're not sure of? When does it need to be handed in by? I don't know. This time next week. I mean, like I said, I'm not expecting everyone to have everything finished. Just give it a good go. Don't spend more than about an hour on it. Although you can if you want to, if you feel that it's necessary for your learning. Aim to spend about an hour on it and get it handed in next week. Okay, but it's not like I'm gonna put you in detention if you don't do it or anything like that. Because I mean, put it this way: 8 people out of 30 something have actually tuned in. Now I know that there's some people that are going to be watching it later at home, but you know, you guys are making a good start. So this is all above and beyond, really. So, any questions before I hit that sign off button? What do you mean out of 32? There's about 32. There's 30 something students that are doing what's it called? Computer science in what is currently year 9, right? Yeah, I know. There's some kids at school. This will remain on YouTube at the same address. So anyone that missed it now will be able to go back and watch it there. I'm not going to penalise anyone for not watching it. It's just like it's going to be useful if you do. Okay, hopefully that was useful to everyone. And cool. My brother said watch. Who's your brother? So I mean, if you learned something, that's great. If you didn't learn anything, but if you learned something that you didn't expect to learn, even better. Okay, cool. That's it from me then, guys. If anyone... Oh, by the way, I wanted to show you my amazing T-shirt here. Look at that. It's a dinosaur vomiting a rainbow. Probably the greatest shirt I've ever owned. So I'm going to try and wear this. If anyone has any requests for specific hats to wear, then let me know and I'll get hold of it. Until next time, be excellent to each other.